Let's take a look at horizontal stretching or compressing. When we have a horizontal stretch or compression, we're going to have y is equal to f of b times x. So we can see that our coefficient that's going to do the stretching or compression is multiplied directly by the x variable. That's how we know it's in the horizontal direction. Now, just like with our horizontal shifts where the direction was the opposite of what we would think, we'll have the same thing for our horizontal stretching or compressing. So instead of multiplying every x coordinate by b, we'll multiply by 1 over b and leave the y coordinate unchanged. What this means is that we'll have a compression if b is greater than 1, because if b is greater than 1, then 1 over b is less than 1, and a horizontal stretch if b is between 0 and 1, because if b is between 0 and 1, then 1 over b will be greater than 1. If our b is negative, we'll take this as two transformations. We'll assume that it's a horizontal reflection in addition to a horizontal stretch or compression. So we'll take the absolute value of b and perform our horizontal stretch or compression and then reflect the graph over the y-axis second. Let's take a look at an example. In this case, we have y is equal to the absolute value of 3 times x. When we look at this, we can see that our library function is absolute value of x, and we know how to graph that. We see that we're multiplying a 3 right by our x. So since we're multiplying that 3, we can see that it's a horizontal compression or stretch, and we know that because it's horizontal that we do 1 over the coefficient, so it will be 1 over 3. So it's actually a horizontal compression by 1/3. So each of our x coordinates gets multiplied by 1/3, which presses the graph in towards the y-axis, and we can see the result of that multiplication by each x coordinate. We can see that our point at the origin doesn't move because the x coordinate was initially 0, and 0 times 1/3 is still 0, but everything else is kind of smushed towards that y-axis. Let's look at another example. In this case, we have y is equal to the absolute value of 1/2 times x. We can see that in this case, our library function is the absolute value of x, and we know how to graph that. Then we know that we have a horizontal stretch or compression because we have a 1/2 multiplied directly by our x variable. Since it's a horizontal stretch or compression, we know that we have to think the opposite. So we do 1 over 1/2, which is 2, and we end up with a horizontal stretch of 2. This will result in multiplying each of our x coordinates by 2 to pull the graph away from the y-axis, and we can see the result of that multiplication by our x coordinates. Again, we see that our origin point did not move because 0 times 2 is just 0, but each of our other points had a multiplication of their x coordinate by 2.